So I'm Kaven Nourrice from Frascold Technical Department. Today I will present to you a couple of examples of air source heat pump for district heating applications. So big sites heat pump with hydrocarbons. After a brief introduction about Frascold and our partners, Solid Energy, we go in some generality, some introduction on heat pump in district heating application, and then we go through two case studies in Denmark, Galten and Longstrup. Just some words about Frascold. Frascold is one of the leading manufacturer of compressor, reciprocating compressor and screw compressor. It is in this sector since 1936. We have our headquarters in north of Italy, close to Milan, and we have branches in China, India, and United States. We have more than 20 employees all around the world, and the production capability of over 70,000 of compressors. Solid Energy, our partners, is a clean tech company, Danish company, that is founded in 2015 and is specialized in heat pump application for district heating, so big sites of heat pump. Now they have in their portfolio more than 40 megawatt of power in capacity. Here you can see some reference about Solid Energy, and highlighted there are the references that we are talking about in this presentation. Why heat pump in district heating? Heat pump integration in district heating system can be very interesting, considering also the issue that all of our know for the repairability of fossil fuel. So using a heat pump in a district heating system can reduce the dependency of fossil fuel. Heat pump integrated in a district heating system can balance the fluctuation in the production of the renewable energy, the electricity and renewable energy. When the electricity production from renewable source can be high, heat pump can be used to produce the heat that can be stored in the district heating system. They can offer also the flexibility for the district heating system, do the fast commissioning of heat pump and the low startup cost compared to other technology like boiler, gas boiler, wood chip boiler or something like that. And the possibility to use low temp and waste heat source as source for the production of heat to heat pump. And clearly the possibility to integrate in the same system district cooling and district heating, that in some reality can be a strong point. The barrier that we can see in the integration in that moment is the fact that most of the district heating system are, the traditional district heating, are in high temperature. So at the moment, there is necessity to produce high temperature heat pump, and we'll see after how to do it. So the challenges to reduce the carbon footprint in heating sector to improve the sustainability, the environmental sustainability are clearly the reduction of greenhouse gases emission, the direct greenhouse gases emission, and the response is clear. Use low GWP refrigerant, and in this case we can possibly use hydrocarbons, and then reduce also the indirect greenhouse gases emission, improve the efficiency of the system, and integrate heat pump in a district heating system. To be integrated in a district heating system, heat pump need to be high temperature water supply. So for the compressor point of view, means high condensing temperature, high capacity. From the compressor point of view, high displacement, so screw compressor. high efficiency in this severe condition. This is Frascold proposal for this kind of application. So our compact screw compressor with ATEX certification Zone 2. We have the largest range certified ATEX Zone 2, from 120 up to 1085 cubic meter per hour, screw compressor certified, with the possibility to drive this compressor also with an inverter drive, with a range up to from 30 up to 70 Hertz. The ATEX certification helps the risk assessment of the system. So the parts that is related to the compressor, to the electrical box, and all the accessories related to the compressor, it's already done by us, our risk assessment on the compressor and all the assembly. For this series, we choose to have a dedicated lubricant, the PAG 150, after a lot of tests in our test rig, and also with some confrontation with our supplier of oil, of lubricant. And clearly, we have at the moment a lot of field tests in the market, not field tests, but a lot of running application. I can say thousands of running application in the world. From the efficiency point of view, we choose a dedicated profile of the screws of the compressor that is able to give the high efficiency, low noise, and low vibration. Here we can see, we can go a little bit deep in the system that our customer realized and designed with our compressor. You can see the application envelope of our CX compressor, compact screw compressor, for two different refrigerants, for R290 and R600A isobutane. You can see these two refrigerants because the system of our customer, Solid Energy, is a cascade system to produce a air source, air-to-water heat pump that is able to evaporate at very low temperature using the low stage in R290 and to deliver very high water, considering that the high stage is in isobutane that is able to condense up to 90 degrees of condensation. So it is the perfect match, a cascade system, isobutane propane, to realize an air-to-water heat pump that need to deliver water up to 80-85 Celsius. First case study is Galten, Galten district heating that was built in 1964, supplies more than 2,000 households and produce 45,000 megawatt hour each year. When the community of Galten decided to replace the wood chips heater to heat pump. They realized the first heat pump in 2019 with an installation air-to-water heat pump with the heating capacity of 3.4 megawatt with 6 ATEX compressor of Frascold of 1,000 cubic meter per hour. And then, after 2 years, in 2021, they install an additional heat pump with the capacity of 7.7 megawatt in terms of heating capacity, with additional 12 CX screw compressor ATEX certified. And now this system, Galten 1 and Galten 2 combined, provide basically all the requests of heat of the community of Galten. You can see some other specification about the evaporator, so 34 flatbed air cooler. The designed delivery water is up to 70 70 Celsius, and the design COP in the average condition in Denmark is 3.4. With these two heat pumps, it is possible to save more or less 19 kiloton of wood chip each year, and avoiding about 1,600 trucks load to bring the chips to the heater. The other case study is in Longstrup, not far from Galten. And in this case, the district heating was built in 1964, supplies about 1,000 consumers. And in this case, the energy mix is quite different because 20% of the heat is covered by solar heat, 60%, so the majority of the heat is covered by the heat pump, and the remaining 20% is covered by a combined heat system with gas, clearly. The total heat production of the system is 60,000 megawatt hour of production yearly. In 2021, there was an installation of the air-to-water heat pump that covered 2.5 megawatt of heating capacity using 6 CX Frascold compressor. And the payback time for this system was 4 years. Also in this case, the scope is above 3. In this case, 3.14. The delivery water is 60, like the case before, and the design COP at 8 Celsius of ambient temperature, the yearly average in Denmark, is 3.43. So, summing up, heat pump is a solution for decarbonize the heating sector in general, and especially the district heating sector. To obtain this, hydrocarbons can be a suitable solution for their characteristics in terms of thermodynamic, and also in terms of that, because hydrocarbons are long-term refrigerant, considering the incoming regulation of EU. To obtain this, it is possible to have high-temperature heat pump combined propane and isobutane properties. Clearly, to enter in this market, it is necessary to have competency and reliable partners, like we think we is. Thank you. Come to say hi, all 6, booth 312. Thank you.